Good afternoon, everyone. I'm Sihua, the team leader for Group B3. So today, we would like to have a discussion about a product, which is the pasteurized reconstituted milk. So according to the Food Regulation 93, the reconstituted milk is defined as a liquid product that is prepared by the addition of water and full cream milk powder, and that will be subjected to the pasteurization, sterilization, or ultra-high temperature. So today, our team will discuss about the planning for the design of the formulation based on the formulation, homogenization, pasteurization, and also the packaging and storage, as well as the quality and safety aspect. So now I would like to introduce about my group member and what are the part that are in charging in.
Hi everyone, I am Afika, who is in charge for the formulation part.
Hi everyone, I am Farah Ain and I'm in charge for the homogenization part.
Hi everyone, I am Laushiki, who is in charge of pasteurization part.
Hi everyone, I'm Amira and I'm in charge of packaging and storage.
Hi everyone, I am Zeti, who is in charge for the safety and quality part.
Hi everyone. So for the first, I would like to talk about the process flow for the pasteurized reconstituted milk. So firstly, the full cream milk powder will be sent for the quality analysis and the water is being preheated. After that, the full cream milk powder will mix together with the preheated water. Next, it will be subjected into the high pressure homogenizer to undergo the homogenization, and followed by the pasteurization, which is the HTSC method. After that, the packaging will be sterilized and the pasteurized milk will be filled in and sealed under the aseptic condition. So lastly, the milk will be stored in the 4 degrees Celsius in the refrigerator. So Afika, can you please share with us about the main ingredient that we can use to manufacture our product?
Sure, Siva. First of all, as you all know, the main ingredient will be the full cream milk powder, which have 26% of fat content, the water, and the additives. But make sure that the water also follow the regulations. However, here comes the tricky part, which is the additives. Okay, the additives are added into the milk to improve the stability and the quality of the milk. There are a few suitable additives that can be added, such as the carrageenans, the sodium alginate, soy lecithin, and many more. But I propose we use soy lecithin.
But what do you guys think is the appropriate percentage for the component in the milk?
Okay, according to Regulation 82 from Food Regulations 1985, it is stated that for liquid milk, it shall not contain less than 3.25% of milk fat content, and it shall not contain less than 8.5% of non-fat milk solid. So the percentage that we have set for the product is 3.5% of milk fat content, which also fulfill the requirement of the regulation.
Afika, sorry to interrupt. May I know how we can get the correct formulation to produce 3.5% of fat in our milk?
Okay, sure, Amira. As you all know, our product is the pasteurized reconstituted milk. Thus, we have to determine the ratio between the milk powder and also the water that we're going to use. I propose to use mass balance to calculate the ratio. As we agreed before, the milk product that we will use have 3.5% of milk fat content. And based on the fat analysis carried out for the full cream milk powder, we have 26% of milk fat. So by using both this crucial information, we can get the ratio to produce the milk product, which is 1 to 6.43, which the 1 stands for the milk powder and the 6.43 stands for the water. So basically, it means that to produce 1000 kg of the pasteurized reconstituted milk, we need around 135 kg of milk powder and around 865 kg of water.
Okay, clear. Thank you, Afika.
Afika, as you have mentioned just now, there are still many additives, but why you specifically chose the soy lecithin as our additive?
Okay, that's a good question. The reason I propose soy lecithin that it is a good stabilizer because it can decrease the creaming rate, reduce the droplet size, and also decrease the interfacial tension in the milk. Hence, our product will be more stable and we can also maintain a good quality.
It seems reasonable. But how about the dosage that we should use? Do we need to use a lot of it?
Okay, for the dosage, I recommend to use 0.6% of soy lecithin in order for it to act properly as a stabilizer. Based on the journal that I've looked up, if you use less than 0.6% of soy lecithin, for example like 0.4%, it can actually decrease the viscosity of the milk, which is undesirable. But if you use more than 0.6%, like 1%, is not recommended as the effect on the stability of the milk is more or less the same as the 0.6% of soy lecithin. In manufacturing, one of the main concerns is the cost to produce this milk. Thus, instead of using 1%, it is better to use 0.6% of soy lecithin to reduce the cost while also gaining the stability that we want.
I think it is good. Alright, thanks Afika. I think so far we are quite understanding about the formulation part. So Farah, can I know why the reason that you put homogenization as part of our processing?
The purpose of the homogenization step in here is to disintegrate or finely distribute the fat globules in the milk in order to reduce creaming. Hence, it can improve the quality of our product. Homogenization primarily causes diffraction of fat globules into much smaller ones. Consequently, it diminishes creaming and may also diminish the tendency of globules to clump or coalesce. Smaller fat globules leading to less cream-line formation, whiter and more appetizing color, reduced sensitivity to fat oxidation, and more full body flavor and better mouthfeel, and also no formation of cream layer. This process basically results in milk of uniform composition or consistency and palatability without removing or adding any constituents.
It seems it's really an important step.
I'm still a bit confused about the equipment that is used here. Can I know more about this?
Sure. In this case, the homogenizer that we propose is the high pressure homogenizer. The parameter for this equipment is 50 degrees Celsius and 365 MPa. The high pressure pump that forces the liquid through a narrow opening, that's so-called homogenizer valve. Homogenization is done by forcing all of the milk at high pressure through a narrow slit, which is only slightly larger than the diameter of the globules themselves. This can cause high shearing stress, cavitation, and microturbulence. The globules become deformed, then become wavy, and then break up.
How about the parameter that we can set to carry out this homogenization?
There are two aspects that we need to consider, which are the temperature as well as the pressure. We set our temperature at 50 degrees Celsius as the effect of the pressure on the size and distribution of fat globules only start at 50 degrees Celsius. Besides, the pressure of homogenization at 365 MPa can inactivate Listeria monocytogenes.
All right. Thanks, Farah, for your explanation. So I think now it is more clear that we should set the parameter for homogenization at 50 degrees Celsius and 375 megapascal. So now, Shiki, can you please tell us more about the pasteurization process?
Yes, the pasteurization method we use here is HPLC method where the milk is being pasteurized at 73 degrees Celsius and hold for 15 seconds. After that, it's immediately cooled to 4 degrees Celsius.
Shiki, there are different types of heat exchanger that are available in the market, such as tubular heat exchanger and plate heat exchanger. So, which one do you think is more suitable for our process?
I suggest to use plate heat exchangers The advantage of using plate heat exchanger in pasteurization process is high regeneration values. Heat coming from the hot milk transfer to the colder milk, and the cold milk going to heat collide in regeneration level and heat transfer occurs. With this energy and time saving system, the process is completed faster and cheaper.
Wow, that is good since it is more economically friendly. But what is the flow rate and number of plates for the plate heat exchanger?
The flow rate is 60 liters per hour and the number of plates used is 50.
How about the dimension?
The single plate is 1070 millimeters high with 238 millimeters wide with corrugated herringbone pattern.
I have a question. Why herringbone pattern?
I know. This special pattern allows the heat transfer to be more effective by forcing the fluid into a high turbulent flow. In turbulent flow, heat is more uniformly distributed in the fluid. The channel structure makes the strength of the plates and the overall heat transfer surface to increase.
Yeah, you are right.
Then how about the flow condition in the plate heat exchanger?
In my opinion, constant current flow operation is suggested.
But how the counter current flow operation occur?
Constant current flow is two media flow anti-parallel to each other. The one medium transferred energy through the thin, strong flow plates between the channels and deliver it to the opposing medium without missing the two media.
Is counter current flow more effective?
Yes, constant current flow heat exchangers are more effective compared to the cold current types, as more heat is delivered per unit time and the heat transfer surface.
Okay, then we will use counter current flow. But how about the heating medium that we are going to use? We are using steam or water?
After finding more on the internet, I find steam heating is more effective than the hot water. The heat transfer by the heat steam does not involve a temperature change. Unlike the hot water, temperature gradients are constantly dropping, resulting in uneven heating. Besides, the amount of latent heat from the steam is released is greater than the amount of sensible heat from the hot water after condensation. Hence, the steam heating has a greater speed in heating process.
Oh, it seems like the steam is a good choice.
Yeah, then steam is good. But how can we hold the temperature of the holding tube at 15 seconds?
Usually, the holding tube is insulated to minimize the heat loss and the drop in temperature. Besides, heating the milk slightly above the set pasteurization temperature in the heating session can also minimize the drop in temperature.
How about the milk heated with the temperature below the target?
There are recording and indicating thermometers followed by the flow diversion device after holding tube. The flow diversion device diverts the flow of the milk to the raw milk constant level tank. If the recording thermometer show below the legally allowable temperature.
I see. I think so far we also understand about the pasteurization part. So we are moving to the packaging part. Amira, can you please tell us more about the criteria for a good packaging?
Sure. Good packaging needs 5 things. It needs to be able to protect our product from damages and outside influences, provide consumers with ingredient and nutritional information, easy to handle and distribute, able to maintain the food safety, and last but not least, able to extend the shelf life of our product.
So what is the most suitable packaging for our product?
Okay, to answer your question, when we talk about milk packaging in general, we have two options, either a single service container or returnable container. Single service container is like milk cartons or plastic bottles. that we need to dispose after a single usage. Meanwhile, a returnable container is like a glass bottle. So for our product, I would suggest to go for the first option, which is the single service container.
Yes, I agree with that. I think that single service container are more popular nowadays.
Yes, that's true. Returnable container are not popular anymore because they are not convenient for both sides, the manufacturer and the consumers. So do all of us agree on single usage container?
Yeah.
Yes.
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 Okay, then do you have any other suggestion for the packaging material?
For the packaging material, how about using milk carton, specifically Tetra Pak? We all know that the food and beverages industry are harsh and competitive, right? So if we want to introduce new product to the market, we need eye-catching packaging in order to stand out in the market. So I believe that with this packaging, we can design colorful layout and has a lot of space to put more information about our product and company.
Oh, really? Is Tetra Pak more superior than other type of packaging materials?
Yes, not only we can be creative with the design, but it is also lightweight, made from renewable material, hygienic, and recyclable.
Oh, that's great. Since they are recyclable means, we will minimize the impact to our environment. So, but how about the capability to protect the safety and quality of the milk? Is it sufficient enough?
Don't worry, everyone. Tetra Pak is actually one of the aseptic packaging system in terms of the materials and the processing. The packaging material consists of six thin layers. From the outside, the first layer is made from polyethylene, which is a type of plastic that acts as a moisture barrier to prevent condensation on the carton when it's taken out from the fridge. The second layer is actually a paperboard that gives the packaging stiffness and stability. The third layer is polyethylene again, but this time act as adhesive for the next layer. The fourth layer is coated with aluminium foil that will protect the product from light, air, and odor. The fifth layer is actually again adhesive, which is the polyethylene, and the last layer is polyethylene, but this time it is to seal in the flavor of the milk. So with this many layers, I'm sure that it can protect our product.
Wow, so many layers in the packaging materials.
Yes, so many layers, right? So besides the paperboard layer that I mentioned just now, also provides some extent of light barrier as exposure to light can affect the nutrient and the taste of our milk. It degrades the methionine protein to methanol. So given all these layers like polyethylene, paperboard plus aluminium foil, the packaging should be able to protect our product from mechanical shock, leaking problem, light, and oxygen.
Can I know the whole process to create the completed product, Amira?
Sure, my pleasure. The operation involves three steps. So the first one is formation and sterilization of the milk carton. The second one is filling and sealing. And the last one is storage before it is finally distributed to the wholesales or retails.
Amira, can I know how the sterilization in milk cartons is carried out?
Oh, okay, that's the first step. The packaging is preformed by placing the roll of the material in the feed of carton packing machine at a very high speed. After that, the formed packages will be sterilized. We sterilize them with hot and concentrated solution of hydrogen peroxide plus hot air.
Then how about the filling and sealing process? Can you explain further on it?
Sure, that's the second step. The filling and sealing process takes place in a aseptic condition to facilitate high standard of hygiene. Aseptic condition meaning that we put them in an atmosphere with overpressure and sterile air. The packaging, after that, the packaging is cut, blow dried, and marked with date and batch number. We need to be extra careful during the filling and sealing process as we want to avoid recontamination of the pasteurized milk.
For storage wise, is it necessary for us to store in refrigeration?
Yes, it is necessary to store the product at refrigeration temperature below 5 degrees Celsius in order to ensure that the milk stays fresh.
Yeah, we need to store it. That's a good explanation. Thanks, Amira. Then we will use Tetra Pak as our packaging. But I still have a bit worried about the safety aspect. As all of us know, the food safety is one of the greater concerns for many people nowadays. So, what are the methods that we are involved in the manufacture processing line in order to keep our product safe?
Milk is highly nutritious product which provides a favorable condition for the microorganisms. Hence, I think we should take it as a paramount consideration in the production of the milk products. Therefore, we use a heat treatment in our processing line. Through pasteurization, we could reduce the levels of the vegetative pathogens, inactivate spoilage bacteria, yeast, but it is quite hard to reduce spore-forming bacteria as they can survive the heat treatment temperature.
Yes, you are right. In order to maximize food safety, we have conducted several methods and techniques. The method used include total microbial count, coliform count, cyclophilic count, and pathogen testing. Total plate count and coliform count are conducted to count the total bacteria and coliform present in the milk. For example, the total plate count should not exceed the acceptable limit, which is 10 power of 5 per milliliter in the milk, and the coliform count should be less than 5 times 10 per milliliter in the milk. We must strictly ensure our product complies with these standards, as the milk would be spoiled and the quality is degraded after this.
Yeah, that's true. It is important to ensure our product is safely to be consumed. Besides the safety part, I think that the quality aspect is also one of the aspects that we should pay more attention on. So, this is because the quality of the product is one of the first criteria that a customer will always look up.
So, what are the aspects need to be concerned with the milk product when considerate about the quality?
As a manufacturer, it is our job in maintaining the quality throughout the processing line, as we have to confront some aspects that could disrupt the quality, such as composition, separation, curdling, and falling.
What are these aspects referring to?
Separations that can be found in pasteurized milk are creaming and scum. Creaming is the formation of fat-rich layer on top, while scum is an insoluble material which can be observed at the surface or as sediment. Next, curdling is which the milk form clump. Lastly, falling is the decomposition of undesired materials on the heat transfer phase. So the heat transfer will not be achieved fully by the milk.
It seems like there are many problems that will affect our quality of the products. Is there any specific analysis that we can use to determine the quality of the pasteurized reconstituted milk?
Yes, they are. Firstly, before the manufacturing, the full cream milk powder has undergone the fat content analysis and moisture analysis in order to ensure it reached the standards that has been listed in the Food Regulation 90 in Food Regulations 1985. Besides, after the product has been produced, we will undergo the moisture content analysis, fat content analysis, and the homogenization test. The homogenization test that has been conducted is the top and bottom test to determine the homogenization index. We must make sure that the homogenization index of our product is always less than 10%.
Good idea, Tati. About the safety issues usually occurs in pasteurized products. Do you think what is the targeted microorganism in the pasteurized milk?
How about Listeria monocytogenes? Because Listeria monocytogenes is a foodborne pathogen that usually occurs in pasteurized milk.
Yes, I agree with that. Inadequate temperature and faulty in pasteurizer during pasteurization enable the pathogen to contaminate the pasteurized milk. Besides, it is able to go over a range of temperatures, including the refrigeration temperature.
Wow. It seems like the Listeria monocytogen is so dangerous. So we will set it as the target microbes in our pasteurization process. Is it okay for everyone?
Yeah.
Okay,
Yes,
okay, I agree with that.
Well, it seems good. Okay, so how do we ensure the suitable time and temperature for reducing the microbe until the milk is safe to be consumed?
Yes, we do calculate D value, F value, and the lethality for the targeted microorganism. Milk is low acid food with pH 6.7 to 6.9. A minimum 6 log reduction of Listeria monocytogenes is necessary. The lethality obtained is compared with the F value at 73 degrees Celsius. In our product, the log reduction to the targeted Listeria monocytogenes is 25, which is greater than 6 log reduction. Hence, the pasteurization condition able to be used in pasteurized milk to produce safe product with desired targeted microorganism to be killed.
Then we can ensure our product is safe to be consumed.
But as far as I know, thermal processing will not only inactivate the microorganisms, but it will also affect the quality and the nutrition inside the pasteurized reconstituted milk. So how can we determine the quality of the end product?
Don't worry about this. We have calculated the cook value for the process. Cook value is the measure of heat treatment with respect to the nutrient degradation and textural changes that occurs during pasteurization processing. It was determined by measuring the extent of cooking while nutritional loss during processing.
So, what nutrients should we consider to determine the quality of our milk product?
I suggest vitamin as our quality attributes as it is an important vitamin and it is very thermolabile. The cook value is derived from the definition of F value. The F value is set as 15 seconds. The percentage of surface retention that we calculated is 98.99%, which means that this treatment is able to retain the quality as much as 98.99%, which is considered as high and showing our product is still a good quality after pasteurization.
Yeah, I think that a high percentage of surface retention is really important for us to determine a good quality of our product. So I think so far we have gone through the every part in the processing line, which is from the formulation, followed by the homogenization, pasteurization, packaging and storage, and lastly, the safety and quality aspect. So I would like to do a little wrap up for today's discussion. Is it okay for everyone?
Okay.
Yes.
Okay. So firstly, we will use the full cream milk powder mixed together with the preheated water in the vacuum mixer in the ratio of 1 per 6.43. So we will follow by the homogenization process at 375 megapascal at 50 degrees Celsius. And during this time, the soy lecithin with 0.6% is added in. So after that, the ST method is applied. Then the Tetra Pak milk cartons are sterilized and filled in the pasteurized reconstituted milk under an aseptic condition. And then lastly, the cool pasteurized reconstituted milk is then kept in the refrigerator at 4 degrees Celsius. Therefore, is it okay if we manufacture our product as the processing flow that we mentioned above?
Yes, okay.
Yes.
Okay, so I think this will be
All
all
is
for today. And thank you everyone for attending today's discussion. Thank you.
Thank
Thank you.
Thank you.
Bye bye.
Bye.